Hello everyone, my name is Anton. Today we have a pretty interesting board and interesting story here. The board is called SpacemiT Muse Pi. It was sent to me for free, but I will try to remain unbiased here. So let's start. Some time ago I reviewed the Orange Pi RV2, and that board left me with a many unanswered question actually. What processor does it use? Why is it branded as AI? Who manufactured it? Why there is almost zero information in the internet about this processor? In the video and article that I did, I speculated a little bit that Huawei might be involved because some packages during setup were downloaded from Huawei servers. And I wasn't the only one with the suspicion. Other people online noticed similar issues. But reality was much more interesting. My review of Orange Pi was at spring, and much later this autumn, SpacemiT sent me this Muse Pi Pro for testing. As soon as I powered it on, I felt strong deja vu. I compared specification with Orange Pi RV2 and Muse Pro, and they looked suspiciously similar. Check this out. At this point, it became hard to ignore the possibility that both boards use essentially the same processor, just branded differently. When I asked SpacemiT directly whether the chip is the same one used in Orange Pi RV2, they didn't confirm it. Maybe they have some NDA, but they did confirm a few different important things. This processor here is totally their development. They provided a lot of documentation about this, and it was super interesting to read this documentation. And of course, thanks them for this documentation, because it was hard to Google this, like Google failed, ChatGPT failed, some of this documentation was in Chinese. So anyway, thanks guys for all this stuff, and it's make my day different, definitely. Because with this information, I finally know what this AI processor meant and what it was for Orange Pi RV2. Why I didn't correctly review it, and why I will review this board fully corrected. So, what is this processor? This processor is Risc-V architecture. If you know, Risc-V, it's a CPU with open source infrastructure. And Risc-V architecture is pretty simple. Of course, it's super complex, but with the Risc-V, you actually can change some parts differently, and you can manipulate them. And what did they do here? So, they extended the standard processor command with custom matrix instruction. So, instead of integrating a separate NPU, which requires drivers, queuing, buffers, SpacemiT added a compact set of matrix multiply accumulation instructions directly and optimized them specifically for neural networks. They did like integrated dot product, sliding window optimization, and floating point multiply accumulation instruction. Here is a small list. And this instruction significantly accelerates the most computational heavy operations in modern neural network. Of course, it's like not the full operation that neural network do, but when you have such operations, you can like simultaneously run neural network on your CPU, but just boost some part with this. And with such approach, you don't need NPU. It's pretty easy to support some runtimes like ONNX runtime, like some Ollama and different runtimes. It's works directly inside the CPU pipeline, and of course it's provides you simpler development, because with this you just need to change a few operations in your neural network. You don't need to rewrite millions of layers and how they behave, how the memory transition works, because in general it's the same. Let's briefly go through the difference of this architecture with classic architecture like Neon, AVX from Intel, and with NPU. So the main difference with classic CPU instruction, which were used for accelerated neural network, because this classical instruction, it's like just some vector instruction, and it's pretty limited. Here it's like matrix instruction, and SpacemiT in their documentation showed that same operation work at least twice faster, like matrix multiplication, but in some cases it can be even 10 times faster on some big matrix and so on, especially with sliding window involved. And if you compare it with the NPU, you don't need drivers, you don't need like memory transfer, no scheduling and balancing on all this scheduling operation. And of course, it's like a little bit simpler for implementation and deterministic. Let's return to question, what was incorrect in my benchmarking of Orange Pi RV2? The main difference, because with Orange Pi RV2, I benchmarked this with regular neural networks. But here, and for Orange Pi, it's super important that all this acceleration working only for int 8 and int 4. And of course, you need to prepare your neural network for this format, and specifically important because if you are working with ONNX, and ONNX here is the main approach because they are providing ONNX runtime, you need to create a quantized ONNX, which is pretty rare. If you are utilizing like this quantized ONNX with smaller images, speed became much better. And actually, here it's like speeds from official documentation. I checked a few of them. The reality is quite close. And for some comparison, it's really look like two tops right here. It's compared with super optimized neural network inference for Raspberry Pi 5, or for some small NPU chip, like with two tops, maybe some Rock chip, maybe with some NXP. And in general, it's work quite nice here. And of course, it's like a little bit easier than different approaches. Also, I need to admit that with LLM inferencing and with VLM and all this other stuff that you can run with Llama CPP or Ollama, it's also possible here, like it was for Orange Pi RV2. And here the speed is exactly the same, and this LLM inference speed, actually it's a little bit slower than for Raspberry Pi 5, which I tested in my Orange Pi RV2 video. But let's, after we go through all these questions, let's return back to this board and speak a little bit about this board specifically, what is good, where you can use it, and so on. I'll already mention that this board is actually close to Orange Pi RV2. But I need to admit that even the simplest model of Muse Pi has more peripherals than the most complex model of Orange Pi. For example, here is memory started from 8 GB, and for Orange Pi it's ending on 8 GB. Here, even the simplest model has eMMC, but for Orange Pi you don't have it. So it's some differences in connectors, some difference in cooling system, and so on. But in my opinion, this board is a little bit more optimized if you want to run heavy neural networks, if you want to focus on LLMs, VLMs, and so on. And this board has pretty unique thing. It has mini PCIe slots. I don't remember any other board with it. So maybe it will be critical for someone. From other perspectives, this board looks like other Raspberry Pi boards and Raspberry Pi different boards. Something better, something worse. In my opinion, it's the main difference of this board is specifically with this CPU and not with the peripheral design. What I didn't like here is that you need connect your monitor for the first run because you need to set up your system here, and it's impossible without entering your login and password, and with you need to turn on SSH access. Maybe it's somehow possible when you're flashing this board, but because board for me was already pre-flashed, I go through all this. But I need to admit that this system has pretty beautiful interface, and but really, I don't use any of my boards as TV boards, I think. Let's speak a little bit about inference. Everything is super easy. You just take on an extra runtime, you just use this provider from SpacemiT, and everything is working. For LLM, NLP, and other models, you have a few different options. You can use Llama CPP, and you can use Ollama. Both of them are working, I checked this, but actually, in my opinion, it's always a big question, what do you want from such small models on such small bursts? Speed is quite nice, it's about from 10 to 20 tokens per second. It can generate almost with the human voice speed, but a little bit slower. Speaking of such models, it's quite nice that you can have this board with 16 GB and 128 GB of memory, and you can switch your neural networks here. So let's briefly wrap up this video. This board was super interesting for me because I go through all this modern Risc-V architecture, and I found a board where all this stuff was implemented. I think this board may be more interesting for some enthusiasts who want to optimize their neural network or the skill of optimizing neural network directly for processors, because it's some easy approach in some way, because you don't need to learn this infinite libraries for CUDA when you're running this, but this device is quite cheap, quite interesting from mathematical perspective, how you can implement all this. It's quite interesting to touch this Risc-V and so on. From classical computer vision approach, this board is nice, but of course there are some alternative from price perspective, and of course there are some alternative with the same form factor because it's super classical. So I don't know if you just need some super cheap device to run through your video feed and generate events. Maybe this board is not the optimal for this, but if you want something new, if you want some new toy which you can utilize for mathematics, for experimenting, if you need a board which can actually infer some complex neural networks, and if you don't want to think about how they work in specifically LLM, VLMs, and so on. Maybe this board is good. It consumes less electricity than Raspberry Pi, so in some application it may be critical. But of course, in my opinion, it's a little bit specific board, but pretty interesting one. Thank you for watching. Hope this video helped you. Bye.